Hello boys and girls, welcome to another session of Kerbal Space Program. We have two more tutorials to do. Orbiting 101. This training scenario covers the basics of flying a spacecraft in orbit. Essential maneuvers like raising and lowering apoapsis and periapsis nodes. And also important concepts such as what the terms apoapsis and periapsis mean. That we will learn. You will start off in a low circular orbit around Kerbin. So the planet is Kerbin. I think I've read it in the Wikipedia that the planets have different names, like Venus is Eve and other. With the Orbiter 1 training craft ready to go. Alright, let's see how ready we are. We are sinking. Altitude is getting lower and lower. Welcome to the Orbiting 101 training program. I'm Gene Kerman and I'm going to teach you the basics of orbiting. I assume you've already done the basic tutorials and are now ready to learn how to get around in space. If you haven't done them, well, I hope you know what you're doing. Let's get started. Orbiting is really nothing more than free falling. Yes, it is. But I think we shouldn't free fall forever. The only thing is that as you fall, you're moving so fast forward, you actually miss the ground. Yeah, that's the first cosmic velocity, is exactly that you're moving forward at the speed you actually not at the speed you're falling, but you the amount of meters you would fall, you move forward so much that the Earth roundedness, that the Earth's surface falls down below you in that same amount. Because up there is no atmosphere to slow you down, you will continue to free fall endlessly around the planet without having to use your engines. Yes, we are currently on a low, almost circular orbit around Kerbin. It's no orbit. I mean, well, we started at 160 kilometers. To get a better view of your situation, press the M key to go into the map view. Oh, look at that, yes. Oh, look, we have here apoapsis and periapsis. So it's like aphelium and perihelium. I know those. When we had astronomy at school, we were taught what perihelium and aphelium is, or apohelium. So periapsis, yeah, it's so the orbit is an elliptic, is an ellipsis. It's an elliptic orbit, and this is where you are closest to Earth, or Earth's surface, or center, and this is where you're farthest. And this ellipsis must have has something like two centers. And one of them is periapsis, the other is apoapsis, depending on where this body we are orbiting is. Okay, this is the map view. Here you can see your ship's position and its current trajectory around the planet. Use the mouse to look around to see your orbit for various angles. You're also hovering over the icons of the map will display more information about them. Yeah, so what is this? Orbiter. Altitude only 117 meters. Ah, okay. Do we have something like time warp? Will it really orbit then? Will it rise? So now 65, and now it's racing again. Ah, look. Wonderful. It really is an orbit. So it was not free falling down to the Earth. Wonderful. Wonderful. How do I... Okay, so let's see. Moon, Minimus. Oh, Sun. Okay. Oh, look at the orbits here. Ah, they are. Moho, Eve. So Moho is Mercury, Eve is Venus. Duna, like Dune, the desert planet where we can mine spice. The spice must flow. First mission is to Duna. Our first interplanetary mission. Maybe not, maybe we will first go to Eve and Moho. I don't know. Dress. So that's Jupiter. Is it really that? That kind of... And oh yes. Joule. So wait, no, dress is Mars, right? No, Mars is this. Mars is Duna. Dress is what? What is dress? Ah, I know. Dress might be one of the smaller bodies. Actually, the planetoids, like Ceres. Do I know any other? Except for the Ceres. There's an asteroid belt actually here, which it's kind of like another planet there, and it has some big ones. All right, and this is Jupiter, Joule, and they left Jupiter, Saturn, Uranus, and Neptune, and they left them out. So, but I see the same anomaly. If you imagine this being the Neptune's orbit, Pluto in our solar system has such an orbit that at times it is actually orbiting closer to the Sun as closer than Neptune because of its eccentric and tilted orbit. It's actually not a planet anymore. Which is right, because its orbit is really so much off from the other planets. All right, so can you have interstellar missions here? I guess not, because this is how far you can zoom out. So no interstellar missions. It would be cool though if you had some kind of magic engine, like I don't know, 1 light year per second velocity, and then you could travel to other star systems. Yes, so Orbit, close the map when you're ready. I'm going to remotely nudge your altitude controls a little. Try to get the ship back under control afterwards. You find yourself totally out of control. If you find yourself totally out of control, hit T to toggle SAS. And are you ready? I guess so. Can I see my orbit? Oh, I'd like to see my orbit because I'd like to know where to navigate. Ready? Yeah, so pitch, yaw and stuff don't work. Yeah, I'm still rotating, but you didn't tell me how do I ignite the maneuvering engines there? I suggest you use the nav ball to orient yourself. Yes, okay. Yeah, I can see where I am, but isn't affected by the camera rotation, so it should be easier. Yeah, but it... can you tell me? How am I supposed to ignite these? Was it in the flight tutorial? Throttle. Shift and control don't work. Well, target is... Oh, I can't see from inside what these Kerbals are seeing. Oh. No, Jean, please tell me. It's the tutorial. It's not an exam. Please tell me. Brakes. Lights. Can you please tell me? Wait. Looks like I got it. Nicely done. No, no, no. Try that again. I have not done nothing. Okay, here we go. So what? Ah. Okay. WASD is working. But try me again. 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 Okay, I think I'm ready. I thought with WASD and QE you control those other parts, but I think that he said something like that once in space you control the thrusters, so it's okay. But is it so hard to repeat this information in this tutorial again? I'm not a stupid guy, but this is tutorials, really. Now let's have a look at the nav ball. You've probably seen the symbols on it. Ah yes, when you're spinning around, here's what they mean. Prograde vector. It points towards your velocity vector. You must explain more. That is, it points to where you're going. No. No. That's as much telling as it points towards your velocity vector. It's not true, is it? This is retrograde vector. And I'm flying somewhere. Somehow. I should be flying directly towards the equator if it's... Except that this is yellow and this is green and this is also yellow. Okay, prograde waypoint vector. It points towards your current waypoint. Okay, we have no waypoints, do we? Points directly away. Why does it return? Okay. Okay, now let's try some little more involved. Open your map again. And what we want to do now is go through some of the basic maneuvers you will need to know. Let's try racing your apoapsis first. Okay, the apoapsis is the highest point in an orbit and it's indicated in the node marked AP. So, how do I raise it? I click it and drag it up, right? No, that's not how you raise it. The best place to raise your apoapsis is the periapsis node, which is the lowest point of your orbit. If you hover the mouse over periapsis node, you'll see that we are going to reach it in a few minutes. Yeah, or hours, right? Because we are flying away from it. Okay, now we are going to reach periapsis in a few minutes. What? What time warp with comma and thing? Okay, that's nice. I totally missed my marks because I wasn't aware that you're talking without me pressing next. Can we do this again, please? Come on. Lifting 101. WASD don't work. Oh, they work. Okay, next. Speed up time a little bit. Just before we reach periapsis. Okay, so we want to raise our apoapsis. Yeah, and how do I raise the apoapsis now? What's this? Is this the moon? Yeah, it must be the moon. Out of training though, you'll have to warp time down to 1 times yourself so you don't go fast to miss the mark. Oh, that's fine, that's fine. Okay, we are a few seconds away from periapsis time to turn prograde and go. But wait, can we pause this? Yes, can we pause? However, instead of closing the map, let's bring up the nav ball here so we can see what's happening to our orbit as we accelerate. To bring up the nav ball to the map, click the little tab. Okay. Good. Time to do our burn. Burn the ship to face the prograde vector now. Turn the ship to face the prograde vector now. Okay. Prograde vector. Wait, it's not yet there. There we go. Okay, we are now turned prograde. We've engaged SAS for you to keep her steady. Really? Yes. Go ahead and throttle up now. I must see this. Throttle up. Apoapsis altitude. Yes. Oh, is it nice? And we see what it's doing to our apoapsis. Wonderful. I understand. I understand. And if you accelerate, oh, and with X you can cut the throttle completely. We are now on the way to apoapsis. Notice how the ship loses speed as we rise. It's because we are climbing away from the planet. Ah, okay. The higher you are, the slower your orbit will be. Notice how the moon's orbital speed is around 540 meters per second, while yours is far higher. Yes, it is. Yes, so we are orbiting faster than the moon. When we reach apoapsis, we will burn prograde again to raise the periapsis. Ooh! And circularize our orbit. What a great idea it is! Yes, that's how you do it. That's how you get on a circular orbit. Okay, I get it. Okay, let's go prograde. And burn. Fuel do I have? Nicely done. This is how you change the size of your orbit. This maneuver should come in handy on many situations. Indeed it will. Next we'll look out changing your orbital inclination. Press next when proceed. Guys, I'm afraid I have no... Well, actually, I have a bit more time, but my recording capacity on the drive is almost full. Next, your orbital inclination is the angle of your orbit makes to Kerbin's equator. Yeah, what? I see. What's Kerbin's equator? Can we have an artificial light shining on our rocket? Orbital inclination. If you've managed to maintain a reasonable amount of control this far, we should be staying nearly 0, yes. That is, even though we've changed the altitude of our orbit, it's still the same inclination as it was before. Yes, I understand. Changing inclination is done by thrusting 90% angles to your prograde vector, but without changing your pitch relative to the surface. Wait, changing inclination. So the equator is this, and our orbit is this, and we want to change the inclination. Changing inclination is done by thrusting in 90-degree angles to your prograde vector, but without changing your pitch. What was pitch? Pitch relative to... Ah, I understand. So the pitch must be as it is. And in 90-degree. Come on. 90-degree. Okay. This should be it. On our present nearly equatorial orbit, prograde is due east. That means no increase in inclination, so that our orbit takes us higher latitudes. We have to burn towards north. Alright, I'll burn towards north. Let's burn toward north. Turn the ship heading 360 and open the throttle. Good, this is how you change your orbital inclination. Is it really? It probably is. It probably is, right? I must think about it before I go to sleep, whether it's possible to change the orbital inclination like this. For these maneuvers, it's always better to do it in the slowest parts of the orbit, in the apoapsis, right? That also means that, but as we have a circular orbit, it doesn't matter where you do it. But it's good to know to do it in the apoapsis. That also means inclination changes on large orbits such as we are now. It's always better to do it in the slowest parts of the orbit, so you don't have to spend as much delta V to turn your orbit around. No, I can't follow. Actually, I can follow, yes. If I imagine the speed vectors in the orbit, it doesn't. But in the apoapsis, in the slower part of the orbit, you don't have to change much delta V, but you have to travel a longer distance to change the inclination by the same degree, so it really doesn't matter, does it? Somebody, if you're familiar with this, please tell me why exactly is it so that you should change it in the slower parts of the orbit. Because I'm now thinking, if you change it in the slower parts, the speed on the orbit is small, as a short speed, and you can have more speed to the 90 degree to change the orbit, but then you have a big or greater length or greater distance to fly in order to incline the orbit by 10 degrees. If you do it in the periapsis, the speed is big, but you only need to change the orbit by to fly a small distance to incline the orbit by a smaller degree, isn't it? So that's something I don't understand completely. Anyway, for these maneuvers, it's always better to do, also keep in mind changing inclination doesn't necessarily mean accelerating to the north or south. It means accelerating 90 degrees headings to your prograde vector. Of course. Next, look into the last essential maneuver you will need to learn: lowering your orbit. As you can imagine, lowering your orbit altitude isn't very much like racing, because there is no air up here. We can use our main engines to decelerate as well as accelerate, because nothing says we have to be facing some direction or another. Also, since our orbit is nearly circular, we can just retrograde and our burn at any time now. So let's do it towards the retrograde vector and start. Yeah, okay, I get it. Stay there. Yes. That's it, you're now on your way back. 30,000 meters is low enough to be in the atmosphere, so you're now on a re-entry course to Kerbin. Once we are below 60,000, or 60,000 meters, the atmosphere will start slowing the ship down so that it won't have enough velocity to rise back up again. Wonderful. This is the end of our lesson now. You can continue doing maneuvers on your own. Wait for the periapsis and do re-entry and land. Don't forget to decouple the capsule and deploy the parachutes. See you on the ground. Wonderful. So let's end this. I won't do any more maneuvers because I don't have any recording time left. I should be at 30,000. What's gone wrong with the music? I want to fly towards the surface. Okay, here we go. It's not exactly the angle I wanted to enter the... Atmosphere, yes. Bob Kerman. Why can't I IVA? Wonderful. What I forgot was that this actually doesn't show you the altitude above ground, but above sea level. Of course, if there are 1,000, 2,000 meter high mountains, we are facing. We will hit the ground much earlier than 0. Yeah, but good to know. A lesson learned. This is not the altitude above ground. This is the altitude above sea level. So we should start braking, I don't know, like 8 kilometers. Yeah, just sooner. All died, I suppose. Killed. Yes. Wonderful. And this was a very interesting tutorial. I kind of rushed through it because have not much recording time left, but I will try to learn as much from it as I can by watching it and possibly doing it again off screen. It was an interesting one. Good to know. Thanks for watching. See you next time.